Homework sheet U9, question 5. In part A, we need to find dy dx from this given expression here in terms of x and y. This is implicit differentiation, so we need to differentiate each term with respect to x, including the y terms. This equation does not start dy dx equals, because our equation didn't start y equals to begin with. Instead, it's going to start with the differential of x squared, which is 2x. Now for this next term, I have a product, so I'm going to have to use the product rule. I'm not going to go through the full formal notation for this one. U equals 4x, v equals y. So I differentiate the first term and keep the second term the same. And then I keep the first term the same and differentiate the second term. When you differentiate y terms with respect to x, you differentiate them normally with respect to y and multiply by dy dx. So the differential of y with respect to y is 1 times by dy dx. I have another term in terms of y that I need to differentiate. Y squared differentiates to 2y times by dy dx. 27 differentiates to 0, and the 0 on the right hand side also differentiates to 0. Now I want to take out dy dx as a common factor on this left hand side and move all my other terms to the right hand side of the equation. So I've got dy dx lots of 4x plus 2y, and that is equal to minus 2x minus 4y. To finish, I just need to divide by my bracket to get minus 2x minus 4y over 4x plus 2y. Every single one of those terms is even, so I can divide all four parts by 2 to get minus x minus 2y over 2x plus y. In part B, I need to find the tangent to the curve at the point Q, which is parallel to the y-axis. This means that my gradient is essentially 1 over 0, or something equivalent to 1 over 0, and that means I need to set the denominator of my previous answer equal to 0. So 2x plus y is equal to 0. Solving this equation, I get y equals minus 2x. Now this fact alone isn't enough to work with. I'm going to have to combine that with my original equation, x squared plus 4xy plus y squared plus 27 equals 0, to actually be able to find the values of x and y that will work for this simultaneous equation. So, I'm going to start with x squared, and then I have 4x lots of y, which is minus 2x. Then I have y squared, which is minus 2x all squared, plus 27 equals 0. If I expand my brackets and simplify, I get x squared minus 8x squared plus 4x squared plus 27 equal to 0. And if I simplify, I get minus 3x squared plus 27 is equal to 0. So, moving the 3x squared to the right hand side and dividing by 3, I get 9 is equal to x squared. So x is equal to plus or minus 3. But we're told that the x-coordinate of Q is negative, so I only need to take the negative square root. Finally, I just need to plug that value of x equals minus 3 into my y equation. Minus 2 times minus 3 is 6. This is a simultaneous equation, so I should always check that my answer does work by plugging it in back into the second equation, the one that I didn't use to check. X squared is 9. 4 times minus 3 times 6. 6 squared is 36, plus 27, and I need to check whether that is equal to 0. I have 9 minus 72, plus 36, plus 27, equals 0. 9 plus 36 plus 27 is equal to 72, so I have minus 72 plus 72